So let me copy 11. Still 394, 11, 11, 4, x to the fourth minus 4x squared plus 6x divided by x minus 4. Good. And also I would like to, later on after this one, I'd like to pick something with a different type of denominator. All these were linear so far. This is linear. I'd like to choose one of these two in which the denominator is not a linear fact, or a linear polynomial. Okay. So, descending order, yes. Missing terms, yes. So, I have degree 4. Degree 3 is missing. I have degree 2. I have degree 1, but degree 0 is missing. If degree 0 is missing and it's at the end, it's okay. But if a missing term is in the middle, then I have to leave space. So 4x to the third, 4x to the fourth, the third degree is missing. Then minus 4x squared plus 6x, and there is plenty of room here. And I'm dividing by x minus 4. The procedure is the same. So x times what is 4x to the fourth. We don't law. Yes? I didn't hear, but I'm thinking that you said 4x cubed. 4x cubed times x is 4x to the fourth, but I have to change the sign because I subtract. 4x to the third times negative 4 is negative 16x to the third, positive 16x to the third. I cannot write it underneath because negative 4x squared, because this is x cubed. It's the only spot where it belongs. Because it's x cubed, not x squared, not x. Good. Gone. Nothing plus 16 x cubed is 16 x cubed. I bring down the next in line. X times what is 16 x cubed minus 4x squared?
cubed.
16x squared. Remember, if this is cubed, the next one has to be lower. Yes, perfect. 16x squared times x is 16x cubed. Subtract. 16x cubed. 16x squared times negative 4 is negative 64x squared, positive 64x squared. Gone. Negative 4x squared plus 64x squared is 60x squared, and bring down the next in line. X, remember this is degree 3, this is degree 1, this must be lower. X times what is 60x squared? Positive 60x indeed. Positive negative 60x squared. Negative 240x, positive 240x. Gee whiz. 246x plus 0. So final question is positive 246. So positive 246x minus 246x. So it's negative and positive now. 8 and 1, 9. We're going to check all this definitely. Again, let me multiply that again. 4 and 2, 16, 18. Yes. So it appears, terrible. It appears that this is quotient 4x to the third plus 16x squared plus 60x plus 246 positive 984 over x minus 4. I don't trust this before I check. Okay, ready. If I do not get this at the top, 4x to the fourth minus 4x squared plus 4y plus 6x, something went wrong. I have to start from scratch. So x times all these, and then negative 4 times all these. X times this. So check. 4x to the fourth plus 16x to the third plus 60x squared plus 246x minus 16x cubed minus 64x squared.
I got a question, Professor.
Yes.
The 246 that you got was why was it not 246 up one more? Up what is that? Because it was 246x. Was it 246?
So 246 times x, and then
Times
2.
X.
Yes. So it was negative 246x.
So why is it 246 up top? Why is it not 246x?
Yeah.
The answer. Okay, but why not in the answer on this axis?
Because 240, so this is degree 3, this is degree 2, this is degree 1. If I put an x here, it's going to be impossible, because 246x times x will be 246x squared.
All right.
Right? So it's a
Yes.
very good point, because it's very easy to make a mistake, especially with all these numbers, right? So you will keep it straight if you always remember degree 3, degree 2, degree 1, degree 0.
Okay.
X to the third, x squared, x, no x. If you go back to x, something is terribly wrong.
Okay.
Okay, very good question. What was I doing? So negative 16x cubed, negative 64x squared, negative 240x, and minus okay, and then plus 984. These two are gone. So I recover the 4x to the fourth. I recovered the negative 4x squared. I recovered the positive 6x, and these two are gone. So I will say yes. Definitely. The answer is correct. Ugly numbers, but the answer is correct. Okay, I think we had enough, but I wanted to show another example with something like either please choose, just for you to see something with 3 terms in a denominator or 2 terms that are not a linear function or expression. So please choose whichever you prefer. 13 or 15.
Let's do 15.
15, perfect. And I was just looking, I'm on page, which page am I on? I'm page 6. Okay, so we want 15 on 394. Perfect. So 18x to the fourth plus 9x cubed plus 3x squared. And we want to divide by a polynomial with 2 terms, 3x squared plus 1. Perfect. Are they in descending order? Yes, they are. Degree 4, degree 3, degree 2. If the last, are missing, it's fine. There is plenty of room. But if one in the middle is missing, I have to leave space, special dedicated space for that. But if the last terms are missing, that's fine. No problem. So 18x to the fourth plus 9x cubed plus 3x squared. There is plenty of room here. So 3x squared plus 1. Can anyone help? 3x squared times what is this? And we don't lie at the top.
6x squared.
So it has to be 6x squared. 6x squared times 3x squared is indeed 18x to the 4th, but I have to subtract. Good. 6x squared times 1 is positive 6x squared, but I have to subtract, but be very careful. Negative 6x squared. Negative 6x squared does not belong here. This is dedicated to terms with x cubed. Okay, good. So this is gone. I bring down the next in line, perform the operations I see. 3x squared times what is 9x cubed? Remember, if we had x squared, the next one has to be lower. Degree.
(3x)
Indeed. So 3x times 3x squared is 9x cubed. We have to subtract. 3x times 1 is 3x. I have to subtract. Not here. Here. Doesn't belong here. It's not the same degree. Negative 3x squared minus 3x. 3x squared times what is negative 3x squared? Careful. Degree 2, degree 1, no degree. And we don't lie.
(-1)
Negative 1. Negative 1 times 3x squared is negative 3x squared, but I have to subtract. In other words, I have to change the sign. Negative 1 times 1 is negative 1. I have to change the sign, and I cannot write it here. It doesn't belong there. So then negative 3x plus 1 is the remainder. 3x squared does not go into negative 3x. And I'm done. Anyway, degree 2, degree 1, degree 0. There is nothing else. Nothing else can follow. The degree has to decrease. And done. It's finished. So then from here, the answer is the quotient. 6x squared plus 3x minus 1. It doesn't matter which sign you use. If you want to use minus, then you have to factor out. Or you can use plus and copy it as is. This is the remainder. It's boxed in. And this is the quotient. 3x squared plus 1. So the trick here was, first of all, careful, because you cannot write under in any event and under any term unless they are like terms. I couldn't put this under this. I couldn't put this under this. And I couldn't put this under this because they're not like terms. I can only combine if they are like terms. Good. Now, let's look at the synthetic division. Any questions on this problem? And yes, we can check. This times these 3, this times these 3, minus 3x. Let's check. Do you want to check? Yes, no? Okay,
Yes,
perfect.
Yeah.
3x squared times 6x squared. 3x squared times 3x. 9x cubed minus 3x squared. Now 1 times this, 6x squared plus 3x minus 1, minus 3x plus 1. 18x squared, yes. 9x cubed, yes. 3x squared with 6x squared, yes. These two are gone, these two are gone. Good. I think you're going to like the synthetic division. The synthetic division does not work in any other case but x minus a number. As an example, x squared plus 2x minus 4 divided by x minus 1. Or x squared plus 2x minus 4 divided by x plus 3. Or x cubed plus 2x minus 4 divided by x minus 1. So remember, when we write x minus a can be positive or negative. So synthetic division has limited applicability. It only works in these situations. When the polynomial at the top can be anything, but the denominator is restricted. It cannot be 3x squared plus 1. It has to be a linear factor or a linear expression, and it can have x plus a number or x minus a number. Okay, so let's look at this one quickly. Here's the, and then we'll practice some more. So in the box, if I have x minus 1, in the box I write 1. Then the coefficients are 1, 2, and negative 4. No missing. 1, 2, negative 4. I leave some room. I draw a horizontal line. I always copy the first coefficient. And I perform the operations as follows. 1 times 1, and I write above the line. Perform the operations I see. 1 times 3, and I write above the line. Perform the operations I see and box in. Since I divided degree 2 by degree 1, the answer must be x plus 3 minus 1, the remainder, over x minus 1. We're going to have plenty of examples in a minute. So I'll stop in just review this, and I'll stop, promise, for 10 minutes. So the coefficients, no missing. What if a missing term? I have to write 0. In this case, nothing was missing. 1, 2, negative 4. I already changed the sign. That we do with a long division all the time. I already changed it here. Instead of writing negative 1, I wrote 1. If it's positive 3, I will be writing negative 3. And that will take care of the sign change all the way. So I copy 1, 1 times 1, perform the operations, 1 times 3, perform the operations, that's it. How do I know what this is? I divided degree 2 by degree 1, so I have to have degree 1. So this must be the coefficient of x, this must be the free term, the boxed in must be the remainder, and the divisor was x minus 1.